Okay, for Algebra 8.7 notes, we are factoring special cases. And in this particular lesson, our special cases are perfect squares. So you might be asking, what is a perfect square? So our perfect squares are the product when you multiply a number times itself. So 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. Let's just do a few more. 10 times 10 is 100. 11 times 11 is 121. And then 12 times 12, let's stop at 144. But perfect squares go on and on and on. So if you have some of these perfect squares memorized and recognize them like right away, if you see 36 and know, hey, I know its square root is 6. Or if you see 100 and right away you know that its square root is 10, you'll be able to solve these trinomials a lot quicker if it's a special case. So let's look at, let's look at how to recognize it. So if you were taking your test, and right away you recognize that the first number in a trinomial and the last number in a trinomial are perfect squares. So for example, I'm just going to go ahead and look down at this practice problem. If right away your first term you know is a hidden 1, and your last term is 36, and you're like, wait a minute, 1 times 1 is 1, and 6 times 6 is 36, that's going to help you go a lot quicker than somebody who's just trying to sit there and go, ooh, what can I multiply to get 36, and add to get negative 12, and it's just going to go a lot quicker. So for example, I'm going to cover up their work. If you know that this last term is going to be a 6, and you know your first term is just going to be 1, or just x actually, then you are halfway done, because right away what you can do is say, okay, I know that I forgot to read the middle term. So we talked about if the first and the last are perfect squares. Let's look at the middle term. If the middle term is twice the product, so remember a while back when I said, I know there's a plus or a minus in here, but pretend there's not, and multiply these together, and then double it. So 6x doubled is 12x. If you can right away see that and know that, well, this is actually a minus 12, so that should be a hint that actually negative 6x doubled is negative 12. And what do you get when you multiply negative 6 times negative 6? You get a positive 36. So so 2 of them is technically the answer, because we've got, if you FOIL it, x times x is x squared. Outsides would be negative 6x, insides would also be negative 6x, and the outsides and the insides are like terms, so negative 6x plus negative 6x is negative 12x, and then the lasts are negative 6 times negative 6, which negative times negative is positive 36. So this is technically the answer, but it's a much more simplified way of writing it. It's the same answer, so you're just going to write it once and then put squared after. So if you know that it's x minus 6 twice, it's better to go ahead and write it like this. So again, if right away you see that that is a perfect square and that is a perfect square, and you know that it's going to be a negative times a negative, because that's the only way to get a positive multiplication answer but a negative addition answer, then you know that it's just going to be x minus 6 squared. Okay, so let's try some of these. So right away, on the U try, you should see that the first one is a perfect square. It's a hidden invisible 1, but really it's x, because x times x is x squared. And 9 is a perfect square. I can go check at the top of my paper. 9 is a perfect square because it's 3 times 3. So let me write this down. And they're all pluses, so it's going to be plus. Is 3 times 3 9? Yes. Is 3x doubled 6x? Yes. So the answer to the factored trinomial x squared plus 6x plus 9 is just x plus 3 squared. And if you want, go ahead and work it out. No one is going to fault you for wanting to double check your answer. Go ahead and write it twice and then FOIL it. X times x is x squared. Outsides are 3x, insides are 3x. 3x plus 3x is 6x. Last times last is 9. So you can check it. All right. Push pause and try part B. on the U-try, and then we'll see how you did. All right, if you're doing it or if you're checking it with me, you should have had x, and that would be a minus 7 squared. So again, negative 7 times negative 7 is positive 49, and negative 7x doubled is negative 14x. So again, you can check it by foiling it off to the side if you want. Now let's move on to, this is a word problem, they're talking about pixels. So it gives us this area of this pixel. It's actually written down right here. I am going to write it down off to the side. 4x squared plus 20x plus 25. Okay, right away, I want you to notice that the first term is a perfect square and the last term is a perfect square. So if you have that, I want you to start by saying, ooh, if it's got a square root, I'm going to put what the square root is. The square root of 4 is 2. And don't forget, since it's x squared, you're going to have 2 of the x's also. And my last term is the square root of 25, which must be 5. They're all adding, so I'm going to put a plus in between. I think this is my answer, but if you want to double check it, it would be, well, it would be the same thing as 2x plus 5 times 2x plus 5. So you would FOIL it by going 2x times 2x, which is 4x squared. The outsides are 5 times 2x, which is 10x. 5 times 2x, which is 10x. Those are like terms. So 10x plus 10x is 20x. And then the lasts are 5 times 5, which is 25. So this was correct. And it was so much faster for me to just look at the 4 and know it's a perfect square, and to look at the 25 and know it's a perfect square, and know that I could just come up with this answer without having to do all of this. All right, we've got another one, and it's a U-try. So push pause again and see if you can factor this one without really very much work. Okay, I noticed that the square root of 16 is 4. Don't forget your m. And I noticed that the square root of 81 is 9. Now, I'm going to choose to put a minus because I know that a negative 9 times a negative 9 is going to be positive 81. And I know a, what would that be, negative 36 doubled is negative 72. So this is going to be the answer. All right, let's look at the next page. This is now going to be a little bit different. Come down here to problem 3. So z squared minus 9. Let's look at this one. I know they have the work there for you, but I'm going to show you over here. What happened is all of these other ones started off as a trinomial. See how there were 3 parts here? This was a trinomial with 3 parts here. But what happened here is it's only a binomial. We only have 2 parts, and we have our a term because that's the first term that's always squared, and we have our c term because that's the part that's just the constant. So what dropped out was the b term. It was the middle term. So the only way to have a middle term completely drop out is if it was plus something and minus something that was the same number. So for example, if you did your foiling and your outsides and insides were opposites, like these two are opposites, they would cancel each other out and they would only leave your a term and your c term. So if you look at it and you're like, oh, this is a perfect square and this is a perfect square, I think the answer is z and 3. You're close. You can't multiply a plus and get negative 9. And you can't multiply 2 minuses and get negative 9. You can only multiply one of each to get a negative. So you're very close in that idea, but you have to have one of each. And that makes sense because when you do your outsides and insides, they are opposites. That would have been plus 3z and minus 3z, which would cancel out. And it would only leave your first term and your last term. So anytime you see a z squared and a minus 9, or a z squared and a minus 81, or a z squared and anything that's a perfect square, but it's minus, you know that there was 2 middle terms that dropped out. So let's take a look at the examples for those. Here we go, v squared minus 100. If the middle term dropped out, it meant we had a v plus something and a v minus something because they were opposites. And the number that's a square root of 100 is 10. So it must have been v minus 10 and v plus 10 that canceled each other out, and it left v squareds for the first and negative 100 for the last. All right, perfect square again, so we can go ahead and say that it's going to be an s and a 4 because the square root of 16 is 4. And we know that if we only have our a term and our c term, that means the b terms dropped out because they were opposites. And I don't care if you put your plus and then minus or your minus and then plus. It does not matter one bit. Okay, push pause and try only the first one of these two U tries. I want to do the second one with you because there's something interesting about that. So go ahead and push pause and you do the first U try. Okay, I noticed that the b term dropped out. So that meant that it's going to be something plus and something minus. All right, so the first square of 25 and d squared is going to be 5 and d, so 5d. And I know that the last term is minus 64, so that would be plus 8 and minus 8. And again, the b term dropped out, so that is why it's 5d plus 8 and 5d minus 8. Okay, I wanted to do the second one with you because actually, I don't know why it's up here with this part. It should be down here with factoring out a common factor. Because when I look at 9h squared and negative 36, this is the last part of this new lesson, but I really need you to grasp this. If you can look at 9 and 36 and know that they're both square roots, they both are, perfect squares, that's great. But I should have taught you from the beginning that anytime you can factor out a greatest common factor from these perfect squares, you should do that first. So it's not mattered before because there's no greatest common factor between these. And it hasn't mattered before because there is no greatest common factor of these. It would just be 1. So it really hasn't mattered until this problem. There is a number that we can divide evenly out of 9 and 36 to start the problem. I hope you guys can remember that 9 divides evenly by both 9 and 36. So, 3 would have too, but it's not the greatest common factor. Anytime you can factor out the greatest common factor, you need to do that first. So the greatest common factor of 9h squared and negative 36 is 9 itself. So I'm going to pull out a 9. I'm going to divide out a 9. And that would leave h squared minus 4. Now that I have factored it down to h squared and minus 4, kind of forget about the 9 for a minute. It's still there. It's going to be part of your answer, but just don't think about it for now. This is a perfect square, and this is still 2. So I understand that it's going to be an h at the beginning, and one is going to be plus and one is going to be minus, and this is a perfect square. 4 square root is 2. So the h's are still there, squared. The outsides and the insides are opposites that would drop out, and the lasts are 2 times negative 2, which is negative 4. So this is the most simplified. Oh, I got to uncover my finger and actually see that 9 is there too. 9 has to be part of your answer. Just because you factored it out, it's not gone. It's just not part of what we look to break down anymore. So this is the final answer. You have to, if you can factor anything out, you have to do that first before you even look at it and see that these are perfect squares. Okay, so let's try this one. What can you factor out of 12 and 48? Because actually neither one of these are perfect squares. You shouldn't have looked at that and gone, ooh, that's perfect square root. No, they're not. Neither one of them are. So let's pull something else out first. You can pull out a 12 itself. You might have thought 6 or 4, but you have to go with the greatest common factor. So the greatest common factor is 12 itself. So let's pull out a 12, and that would leave t squared and minus 4 on the inside. Okay, and now we're not going to look at 12 for a minute. This is a perfect square root. This has a perfect square root. So it would leave t plus and t minus 2. Because the insides dropped out and it left us with only an a term and a c term, the square root of 4 is 2, and how to get a negative 2 is by multiplying a positive times a negative. Now don't forget your 12 is still there, so it's still on the answer. All right, is there a greatest common factor we can pull out of all three of these? Yes, there is. You can pull out a 3 itself. So let's pull a 3 out. That would leave 4x squared. Hint, that's a perfect square. It would leave plus 4x in the middle, and it would leave 1 at the end, because 3 times 1 is how we get to 3. Hint, that's another perfect square. So, if you know that this has a perfect square, you could go ahead and write it at the front. If you know this has a perfect square, you could write it at the back. And I know that they're both adding, so I'm just going to put a plus in between. And I'm going to check it. Okay, so I actually could have gone ahead like I have been and written it out twice. First times first, 2x times 2x is 4x squared. Outsides are 2x plus insides are 2x, so 2x plus 2x is 4x. And lasts, 1 times 1 is 1. And don't forget, we factored out that 3, but it's still part of the answer. But it is a more simplified way to write it. If this is the exact same number twice, let's just write it once, and let's just put a squared at the end. Okay. I believe, let me check and see if we have one more page on that. Nope, the next one is 8.8. So you might just review this and be sure to do your homework practice over it.